Hello guys, welcome. So today we are going to do a physics question. Okay, so this is question 14, A and B, about work and energy lah. Alright, so let's start. So with question 14A, how much work done required for 80 kilogram boy to accelerate from rest to 3.5 meter per second. So this is from rest, which means u equals to 0. So this is the final speed, 3.5 meter per second. Okay, in order to find the work, what we need to do is to find, because the work is defined as the product of force and displacement, so we need to find the force and the displacement. From here we see that at t equals to 1, okay, so we can assume that the acceleration to be 3.5 kan, 3.5 meter per second square. So at 1 second the boy will move at the speed of 3.5 meter per second. So the acceleration is 3.5 meter per second square, and the velocity is 3.5 meter per second as the question wants. Okay, and the value of u is 0 lah. So we can find the force first. Force is defined as m times a, which is m is 80 kilo times acceleration is 3.5. Thus the value of force is, just press the calculator, 280 Newton. Okay, and then we need to find the displacement. We can use kinematics equation. I think it's the v square equals to u square plus 2as. So you want to find s. Okay, v is 3.5 square equals to u square 0 square plus 2a is 3.5 meter per second square, and s. So s is 3.5 square divided by 2 times 3.5, which is 3.5 divided by 2. Okay, 1.75 meter. So the work is F times S, 280 Newton times 1.75 meter is about 490 joule. Alright, so it's pretty simple. Next we see question 14b. Okay, 6 kilogram box is initially at rest, which means u equals to 0 again. Pulled to the right along the horizontal frictionless surface by a constant horizontal force, F equals to 12. So we need to find the speed, which is the final velocity of the box as it moves, 3 meters. So S equals to 3 meter. Okay, first of all, let's draw the diagram, free body diagram. So this is the box, 6 kilo, and this is the horizontal surface. It is pulled to the right by the force of 12 Newton. Displacement 3 meter. Okay, so we need to find the acceleration lah, because we are given the u and also the v. U and s. We need to find v. So we can find acceleration first. F equals to ma. F is 12, m is 6, a is unknown. So a equals 2, so 12 divided by 6 is 2 meter per second square. And then we can use kinematics equation, v square equals to u square plus 2as. We need to find v only, so we can square root both sides. So u is 0 square, 2a is 2, s is what, 3 meter per second. So v is 2 times 2 is 4 times 3 is 12, so it's square root of 12. meter per second square, sorry, per second only, which is approximately 3.464 meter per second. Right, so it's pretty simple. So let's continue with the second question, sorry, question 15. So this is about the work and also work done, sorry, work and energy still. So a 3.0 kilogram box is lifted vertically from rest to a distance 2 meter with a constant upward applied force 60 Newton. Calculate A, the work done by the applied force. So I already draw the diagram over here, so you can see lah. So 15A, the work done by the applied force, the work done is defined as the force times the displacement. So the force, of course, is 60 Newton times the displacement is 2.0 meter upward. So this is 120 joule. B, the work done by the gravity. Okay, so the gravity, sorry, the work done by the gravity is due to the weight of the box. So weight is 3 times the G. So G is, I use G equal to 9.81 lah, meter per second square. Okay, so work done by the gravity equals to the weight force times the displacement. So the weight force is in the negative direction, so I just put minus W, or you can do like this, W equals to W times S lah. So W is defined as M times G. So G is negative 9.1 kan. Okay, M is 3 kilogram, G is negative 9.81 because it is to the negative downward direction. Okay, M per S square times with S. S is 2 meter. So we can get the answer to be about 58.86 joule. Okay, negative, right? So you need to consider the negative. What about question C? Okay, let's see. The final speed of the box, right? The final speed. Okay, you need to find the acceleration first. Okay, so F equals to ma. Okay, so the resultant force should be the F minus W kan, equals to ma. M is 3, A is we don't know yet. So F is 60 Newton upward minus the weight force is 3G, which is 3 times 9.81. 3 times 9.81 equals to 3A. Thus we can find the A. 60 minus 3 times 9.81, then we divide by 3 is 10.19 meter per second square. Alright, so we can apply the kinematics equation. V square equals to U square plus 2AS, right? Because it is initially from rest, U equals to 0, so we need to find the V. A equals to 10.19 meter per second square, and displacement is 2 meter. Alright, so we can subs the value. Okay, so V square, so V equals to U square plus 2AS square root all, right? So V equals to U square is 0 square plus 2A is 10.19 meter per second square times with displacement 2 meter, so V square root all. V is 2 times 10.19 times 2, V square root is 6.38 meter per second. Right, so yeah, that's all. for this question, two questions, 14 and 15. Right? Thank you.